Hello, friends. I have someone very special here with me today, my friend Palmyra Geraki, who is an architect, and she's going to answer some of our questions that we came up with as a class. Thank you, Palmyra, for being here.
Thank you for having me. It's very nice to, I guess, be presenting in front of all of you, even though I don't get to meet you, which is very sad, but I hope to.
Maybe
one day, very soon.
I'm taking a look at the questions we came up with, and our friends asked you, what kind of buildings do you design?
So I design all kinds. I have designed skyscrapers. My tallest one was 61 stories. I've also designed affordable housing, a clinic, a school, office buildings, corporate campuses, student housing, multifamily residential, single family homes. I also do interiors of homes, so all kinds of stuff.
Wow, that's amazing. Someone said their favorite part of a house is a roof and wanted to know, what's your favorite part of a house?
I think the roof is a great choice, but I think my favorite parts of a house are a reading nook or the library, if there is one, of course. And if there isn't, I really like stairs.
Oh, yeah, we had another friend who really liked stairs in there. And I see you have quite a library behind you.
That's right. I really do love books, hence why I love reading nooks, if we can have them.
Yes, we love books too. So you're in good company. You said, I'm going to skip ahead to a question about the biggest building you've ever made. It sounds like you said the tallest building you've made was a skyscraper with 61 floors. Someone asked, how do you decide the size of the building you'll make? And how do people make buildings that are so tall?
Yeah, so I think that's a really excellent question. And it's actually very difficult to answer. So usually when you work with somebody as an architect, you have somebody who asks you to build a building. We call them clients. So they typically have an idea of what they need when they come to you. Like they approach you to build a house because they need a house. So usually they have an idea of how big they want that building to be. But very frequently you have to actually help them figure out exactly what they need and how much space that's going to take up. But the starting point tends to be sort of what their needs and desires are. And also sometimes as you're designing something, it can get smaller and bigger depending on what things sort of happen. The tall building question is also a really excellent question. So people build tall buildings using basically the same materials that they used for smaller buildings. There's a lot of concrete and there's a lot of steel. Lately, actually, there have been some very tall buildings, not skyscrapers, but several stories tall that are made entirely of wood, which is very exciting. I think the key to building a tall building, and I've worked on a lot of those actually, is to work with engineers, especially structural engineers, who can help you figure out how big the columns need to be in the beams. So basically how to support the building. And actually, how to hold up the weight is probably the easier question to answer. The most tricky thing with tall buildings that tend to be kind of skinny is how to stand up to winds and earthquakes. That's what we call like these side-to-side or lateral forces. That's what we call them. So once you figure that out, then the other really difficult part is you have to have a good plan for how to put it all together because it's a very complex task. So construction crews have to work really hard. For architects, tall buildings are also kind of interesting because one thing maybe some of you realize is that tall buildings require elevators to get you up and down. You don't really want to be going up and down in a 100-story building with stairs. And so elevators take up a lot of space. The other thing that maybe some of you might have seen it if you sort of go to downtown Chicago and go to a tall building is that usually you don't have an elevator that serves all 100 floors of a tower. Both technology and experience says that it's actually, just think about it, right? You don't want to wait for an elevator that might have to stop on 100 separate floors. So usually what happens is you want to have an elevator that goes to about 20 floors, so it doesn't get extremely sort of long and cumbersome to wait for it. And so what ends up happening when you have really tall buildings and a ton of elevators, they take up a ton of space. So once you figure out where those go, and then you figure out where the stairs go, because it's really important to be able to leave the building if something happens, like a fire. You basically have most of the skyscraper designed. And then you have to figure out what goes on the outside, you know, what material to sort of put on the outside of the skyscraper, and there it goes. You're ready to go.
Thank you, Palmyra. Yes, I have noticed that sometimes when I go downtown, there are elevators and it'll say floor, you know, one elevator for floors 1 to 20 and another elevator 21 to 40. So that makes a lot of sense.
Yeah.
And hopefully, friends, maybe if people haven't gone to downtown as much, hopefully when the coronavirus is over and more people get their vaccine, then you can explore more downtown and see some of the things Palmyra is talking about. You mentioned an engineer that you work with to see so that the building doesn't move in the wind. Oh, that would be
exactly.
So great, and how the weight is held up. A friend asked a question about an engineer. He said, we read a book that told us engineers work with lights. And so he was curious about refrigerators, freezers, and lights, and how you work with an engineer, and if you work with an engineer on those parts of a building.
Well, the general answer is that yes, I work with a lot of engineers, not just one engineer. So I mentioned structural, and that's like how things stand up and how they don't sort of move too much, because everything moves, by the way, just not too much in the wind or in an earthquake. But there are other kinds of engineers.
Palmyra, you're telling me the buildings move in the wind?
Absolutely. And really tall, skinny buildings move a fair amount. Like, it's noticeable. But, you know, the question, in fact, it's actually good for the buildings to move, because if they're too rigid, then they won't really be able to sort of respond to those different forces that are coming. So yeah, absolutely, buildings move. The bigger and sort of fatter the building is, the less it will move. But tall, skinny towers absolutely sway in the wind. And that's normal.
Wow, friends. I don't know. I'd be a little nervous if I felt it swaying, but that makes sense that, you know, maybe because in Chicago, we have really strong winds. And so, yeah, maybe you need to give a little or the wind might break it.
If you're not comfortable with that, then you should not live in an apartment on the 60th floor of a skinny tower. But yeah, it absolutely happens. But yeah, that's one type of engineer. There are other types of engineers. I work with mechanical, plumbing, electrical, fire protection. Those are the people that do all of the sprinklers in the buildings. And then there are other types. Sometimes they're engineers, sometimes they're just specialists that I also work with, from lighting experts, because you mentioned lighting. Sometimes they're lighting designers, they're food service specialists for restaurants. You mentioned fridges and freezers. That's why I'm bringing it up. Audio-visual, security. So all of those people you work with, like really big buildings, but even small buildings today are very complex. And so you have to work with a really, really big team to make them happen. So lights. Some engineers work with lights. So usually electrical engineers work with lights. They decide where the electricity comes into the building and how the wires are going to be sort of run to the different outlets, right, where you plug things in, and also how they get to the different lights and the different appliances in kitchens and stuff. And then it's architects and lighting designers that decide what those lights look like. For fridges and freezers, when I work on on houses, I frequently will be the one to actually sort of help somebody pick a fridge or a freezer and work with the contractor to sort of put it in place and connect it. But if I'm working on a bigger building and I know that I'm leaving a space for a restaurant, but I don't know what restaurant it's going to be just yet, what I do is I work with the engineers to make sure that when they want to put in a fridge or a freezer and all their lights, that they're able to. So we have all of the connections ready, but then they're the ones that come in and sort of put them in place when they need them.
Interesting. So friends, sometimes the architects will help their client, that's the person they're making the building for, designing the building for. Sometimes they will pick it out for the client, the refrigerator, the freezer. But other times, like Palmyra said, if she's not sure what restaurant is going to come into the building she's designing, then they just leave an empty space for the refrigerator or the other appliance.
Exactly.
Thank you, Palmyra. What's under the floor of a building? And is the floor flat because we walk on it?
Yeah, so those are really great questions. So what's under the floor of the building? There's a lot of different things under the floor, and it really depends on what the building is made out of. And so if you have a building that's made out of wood, and there's a lot of such buildings in Chicago, especially homes, apartments, and houses, then usually under the finished floor, like the wood slats that you walk on, or whatever else it is, tile, right? There is sheets of plywood. And then under that, you have wood framing. So that's wood beams and what we call joists. So it's pieces of wood that are about yay big, right? That basically hold up the floor. And then those are supported by columns. If you have a building made of steel, under the floor that you walk on, you have a concrete, and it's sort of poured, concrete is sort of liquidy, right? It's poured over a steel deck. And then that deck is supported by steel beams. So those horizontal steel pieces. And those are supported by columns. Concrete, if the building is made out of concrete, it's a little different because basically the floor you walk on is just a few inches of solid concrete. And then inside that, you have steel rods that we call reinforcements that basically sort of hold the concrete together. And then that concrete is supported by columns, concrete columns. So, and there are other types of construction too, but I think those are three very frequently encountered ones. And so it really depends on what your building is made out of. The question about why the floor is flat is really excellent. And floors are not necessarily always flat, first and foremost. So they're not always flat, sometimes by design, right? You have ramps or you have big sort of areas where the floor or the ground is sloped, because you have to deal with what the ground actually looks like. But sometimes they're unintentionally not flat, right? Construction is not perfect. I'm sure you've encountered this in your homes. So there are limits to how sloped, right, a floor can be, where you can actually walk on it and not slide off or be very uncomfortable. But also, it's really...
Some preschoolers might think that would be fun if their floor was a slide, but I agree, wouldn't work the best if you were trying to go about cooking in your kitchen or sleeping in your bed.
Exactly. So, I mean, you can make a slide, but you don't have to make your entire floor be sloped. But I think generally the answer is that floors are flat because of gravity, right? You want the floor to be parallel to the ground. Because we experience gravity sort of perpendicularly to the ground. And so when we stand, we want to stand upright, right? You don't want to be on, like if you're standing on a floor, even if the floor is sloped, you still want to stand like this. You don't want to stand like that because you're going to fall over. And so I'm sure you all know, if you've tried to sort of climb something steep, that it actually takes a lot of effort and it's kind of uncomfortable to be on a really steep slope. So and it also can be disconcerting, like you lose your balance. And so if for things that you do all the time at home, you want to be, for the most part, on a flat surface. And then practically, you have furniture and you have plates and books and all kinds of things that you don't want to have fall off the floor. So that's another reason to have a flat floor for most surfaces in a building.
That's a good point. It would be really fun to slide, but then all your plates would slide off, all your food would get on the floor.
Exactly.
I had another question, Palmyra. So you were saying then under the floor there are columns. So do these columns go into the ground, all the way into the ground, that help support the floor?
Well, it depends on what floor you're on. They will be in the floor below you. And then if that's the first floor, then they will go straight into the ground. Eventually, everything, like the weight, imagine it's a force. I know you haven't learned that yet, but basically everything that weighs something, all of that gets transferred through things that are perpendicular to the ground, and it does go into the ground one way or another. So maybe even if the column that you're being supported by directly doesn't even go to the ground, there will be other columns that support that column that will eventually sort of have to go all the way into the soil.
I see. Yes, and friends, when Palmyra says perpendicular, that's a really big word, but perpendicular just, no, it's okay, Palmyra, I'm going to explain. So if this is the ground, something perpendicular is like knocking into, sort of running into it, but something parallel means it's going this way and the ground is here, so they don't connect. But if it's perpendicular, that means it connects to the ground. Yeah, they're both p sounds, but perpendicular is this way and parallel is this way to the ground. It's a little tricky. Maybe we can think of other examples of that. It's a good concept to know, friends. Friends, we're also curious about if you use a toolbox and wear a hard hat.
Well, I have a toolbox and I use it around the house, but I don't actually, and I also know how to use the wood shop, for example, but I don't actually do a lot of the work on the construction site myself. That's what contractors do and construction workers. So I have a toolbox. I don't use it at work. I use it at home, but I do have a hard hat and I have it here with me. Here it goes. And so I guess there are different places of work. So when I'm working in my office and I'm designing things, I don't wear a hard hat, obviously. But when I go to visit a building that's under construction, because things are still under construction and it's very dangerous and things might fall on your head, I and everybody else who goes there always wear a hard hat.
That's good. It's good to be safe, friends. I've heard Palmyra talk a lot about safety, like when she talked about making sure a building has stairs so that if there's a fire and you can't use the elevator, you can still get out, and the sprinkler system for the fire. So now the hard hat too. You have to think about safety a lot. Another friend asked, what materials do you use? And I think this was a question about building materials. So you mentioned earlier that some skyscrapers have steel, but you've also worked with wood, and you talked about pouring concrete into the floor. Maybe are there materials that you prefer to use?
Well, I prefer to use materials that are good for the environment, or at the very least, better for the environment. Everything entails some kind of waste. So minimizing waste and using materials that are friendlier and don't produce bad things in the air and harm all of us and the environment. So that's my preference, but there's many different kinds. So yeah, I use different kinds of wood. I use a lot of metals, not just steel. There's also aluminum, there's bronze and copper and brass, but each one of them has a different use. So steel is very strong, so we use it for structures, like to support things. Aluminum is very useful and it's kind of light, so we use it on the outsides of buildings a lot. And then bronze and copper and brass are much more expensive and rare, so we use them for sort of special things, when you want to make things very pretty. I use a lot of glass, obviously, because it's nice to have transparency. And then even with glass, you have to be very careful, again, because you want to be friendly to the environment. You don't want to have birds sort of flying into the glass. You want to also make sure that the glass isn't very reflective so that it bothers the neighbors. You want to make sure that it isn't the kind of glass that, when you're inside it, you're almost like in this space that gets really hot and annoying. So you basically have to be very careful. There are many different kinds of glass. I use a lot of different concrete products too.
Palmyra, can I stop you there and say something? So Palmyra, friend, said that glass is good for transparency. That's another big word. That means something you can see through. So if a glass is transparent, it means you can see through it. Just like you might have glass in your window and you can look outside. That means your window is transparent.
Yes, I'm not sure which words you're learning. So anytime I use one.
We use many different words, Palmyra. Cool. But yeah, that's really interesting. I didn't think about how glass could be so different, but it's true. So that's really interesting that there's so many different kinds that you have to choose from based on sort of I guess, the effect you want to create and how you want your building to look or how you want the space to feel inside.
Yeah. Absolutely. And then, yeah, there's so many other materials. I could go on forever, but, you know, many things that I'm sure you know, like marble and granite and quartz and terrazzo, those are all similar kinds of things. And then tiles, you know, porcelain, gypsum board, that's what usually a lot of the walls and ceilings are made of, plaster, even paint, fabric, even some plastics, which can be very useful, but I try to avoid them because many of them are not very good for the environment.
Yeah, that's really important to think about. In upcoming weeks, we're going to be learning about gardens, friends, and I think that's going to lead us into thinking about recycling. I know we've used at home, y'all have used recycled materials to make different things. One person made a rocket out of some cardboard and plastic cups. So that's a very good point, Palmyra, that we don't want to be wasteful. So it's good that architects think about that and how not to waste materials or create things that are bad for us in the air, pollution.
Yeah.
Just a few more questions left, Palmyra. Thank you for your time. A friend asked, where do doors come from? And it sounds like you mentioned I bet doors can probably be a lot of different materials as well.
Yeah, absolutely. I think most of the doors that many of you are familiar with in your homes are probably made out of wood. But even wood doors are very different from one another. Sometimes the whole door is one big piece of wood. Sometimes there is a frame around the door, and you can understand that by sort of knocking on it on different parts of the door and seeing the different sounds that you can hear. And then in between that frame of the door, you can have either a different kind of wood or you can have glass or something like that. But you can also have doors that are made out of steel, out of aluminum, glass, all kinds of materials, really. But I guess I'm not sure what the question is really about, if it's about materials or it's about what doors are actually doing. But I think the reason to have doors is because people really want to be by themselves sometimes. They want to be, or with others, but just the group of people that choose to be together. And so I'm sure you feel that way yourselves. Sometimes you just want to be in your room and you don't want other people to see you, or you don't want other people to hear you. And so that's the main reason for having doors. But you want to be able to suddenly decide not to be like that and to be able to actually come in and out, or to leave the door open and have people sort of be able to see you and hear you for a little while. So that's the reason why we have doors, and then we can make them out of all kinds of different things.
Yeah, that's really helpful to think about what do we use a door for, not just where they come from or what they're made of. So thank you for that. Maybe friends at home, y'all could go around your house and knock on your different parts of your doors, like Palmyra said. See if they sound different in different places, and really notice if all your doors are the same in your house or if they look a little different from each other. We talked a little bit, Palmyra, about blueprints in our class. Those are the plans that architects make, right? Before they build something, they design it on paper and draw out how it's going to look. And some friends were curious, are blueprints blue? Are they really blue?
So that's a great question, because blueprints were really blue when they first sort of were invented or created. And that was like more than 150 years ago. So what they used to look like, and I might be able, I don't know if you showed any photos, if you shared any photos, but I just pulled an image just to show.
Yeah, we'd love to see a picture of a blueprint.
It's
in person.
It's not something that I've worked on personally. So because obviously, you know, none of us that have been practicing architecture in the last few years actually have had to do any blueprints. But this is what blueprints actually looked like. There were white lines on a blue background. And that's why they get their name. So can you see?
Yes, I can see that. It almost looks like chalk or something.
Yeah, actually, I don't know if I should get into the details of this, but it was a very interesting process where people actually made their drawings using ink on paper. So the drawing itself was on a whitish background, and then it had sort of a dark ink. But then in these, the blueprints were actually copies. So they weren't necessarily the original drawings, which usually were kept by the people that made them. They were the copies that were given to other people, to contractors, to make the building out of them. And so what happened is you put the original drawing on top of sort of a special type. Oh, you actually know, you used a special paper, which I have here. It's called tracing paper. And it's kind of translucent. That's another word, right? It's not transparent. Transparent, you see everything through. Translucent means you see a little bit of what's behind. Like, I think if you're here, you can kind of see
we can see the shadow of her hand behind.
Exactly. So you basically put the piece of paper like this on top of the drawing, and then you traced everything that you had drawn, and then you put this special paper together with another paper together and with a piece of glass, and then you expose them to the sun. And so what happens is, like, the translucent part allows ultraviolet light through, and that's what makes the paper blue. But then the ink blocks the light from coming through. And so every part where there used to be ink now is white because the light wasn't able to sort of come through. I can show you what drawings look like today, which we do them primarily on the computer. And then we just print them on a printer. And so this is a drawing I worked on a few years ago.
Yeah. So you do it all on the computer now?
Some people, like old school people, will still draw by hand, and we do a lot of sketching by hand, but a lot of the equivalent of blueprints that we give to contractors, just to be very accurate and to be able to reproduce them and print them again, we actually do them on the computer.
Do you still call them blueprints, or do you call them something else?
Sometimes, I mean, I think, yeah, people do call them blueprints sometimes, but for the most part, we just call them drawings, and then we use specific words to describe how detailed the drawings are. But people in conversation will still call them blueprints.
Okay. So sometimes, friends, blueprints can be blue. Back in the day, in the old times, they were blue. And now they might not be blue. They might look black and white like Palmyra just showed us, but people still call them blueprints at times. Thank you, Palmyra. Well, the last question, a friend in our class has pets at her home, and she asked, can you please design a house for my kitty, Luna, and a house for my dog, Manny?
So absolutely, I already have some ideas, and I will share them through your teacher, Anna, at another time, so she can show you. I will send the drawings, and she can show you.
Thank you. And I know this friend had some other ideas that I sent along to you in an email.
Exactly.
She's your client. We have a client.
Exactly.
Yes. Amazing. Well, thank you so much, Palmyra. I've learned a lot from you, and about thinking about different materials and how buildings move, and doors and all the different kinds of glass. And so I thank you so much for speaking to our class, and hopefully one year you can visit our classroom in person.
I would love to. Thank you for listening to me and for giving me the opportunity to do this with you.
Thank you, Palmyra.